Assalamu alaikum everyone, welcome back to MS SQL 2016 comprehensive workshop. In the previous lecture we have seen how to start SQL server, how to connect SQL server, and now before creating a database I must tell you some of the important techniques that you should implement before creating a database and before creating a software. It is not like you just right click on SQL server and create a database. You have to carefully plan your database and then you should continue creating your database. Okay, so in today's lecture I am going to tell you how can you plan your database. Okay, so the first thing in database planning we see is to create a diagram, and that diagram is known as ER diagram. And what does ER means? ER means entity relationship diagram. So I am now going to demonstrate a scenario in front of you. Let's say if I wanted to create a database of a educational institute, so what should be the constraints that you should focus, what are the tables that you should create inside your database. So all are the questions that are coming in your mind. You should analyze that questions, you should answer that questions, note it down somewhere and create a diagram that is known as entity relationship diagram. If you create this diagram, there are 90% chances that you are then correctly create the database. If you do not plan that ER diagram, then you will definitely do some mistakes while designing and while creating the tables and the columns inside that tables. I hope it is clear to everyone. So let's create an ER diagram and let's have a scenario on which we have to create our ER diagram, and we'll see this particular scenario throughout the SQL workshop. Okay, so let's see. Right, so the first thing that we do is to plan. So let's say I wanted to create a database for an educational institution. Okay, educational institution. So what things are required? The first step while creating an ER diagram is to think about your current data that you have. If you have an educational institution, first step is to think what are the physical existing things in that particular scenario. If that is my educational system, let's say, so what are the physically existing entities we have inside that particular school or institution or coaching, whatever you can say. So the first thing that we should have are the faculty members. Let's say faculty members are those members that exist physically. I hope it is clear to everyone. Now likewise there are so many physically existing things that you can think and write it down. Okay, so after faculty, what you have next? You have the classes. So can you write here badges? You have the badges that exist physically, and more than you have the students that are also exist physically. Okay, so likewise you think what are the things that exist physically and note it down. Just I have noted it here. I hope it is clear to everyone. After thinking that these are my physically existing things, step 1, let me write here, step 1 of entity relationship diagram. So that's my first step, and let me write here, find out physical existing things. Okay, so you have find it out. Okay, so guys, for the particular time being I'm stopping here. I'm just taking the 3 physically existing things from my existing scenario. Okay, now the step number 2. Step number 2 should be that after finding the physically existing things from your existing data or from your existing scenario, you will find out the attributes of that physically existing things. What are the attributes? Attributes are the properties basically. Let's say a human being, you cannot say that look at that on the road the human being is going, you say that Prime Minister is going, you say that the Muslim is going, or Christian is going, or Hamad is going, or Wakas is going. You identify with a particular name, you identify that particular thing with a particular name or a particular age or particular gender or a caste or a religion or somebody or something else. So that's what the case. You have to find out what are the properties or the attributes of the physically existing things that you have noted down. So let's talk about the faculty first. So what your faculty should have physically, the name of the faculty. Okay, if we say in terms of our database and software, so do we have the ID of the faculty, the ID of the faculty, the name of the faculty, what else you have? after that name, right? So name, and then what else you should have with your faculty, let's say the phone number. So it's up to you what number of attributes you are specifying for your particular physically existing thing. I hope it is clear to everyone. Okay, so and it depends on the requirements also, what the client is saying to you, that the client says that you need the name, you need the phone number, you need the age, you need the email, and you need everything that the client says. So you can create the attributes. The first thing is this, and then the second object is the badge. Okay, so in badge, what are the physically existing things here, or the attributes of this badge? So of course the ID of the badge, and then the name of the badge, and then the timings of the badge, and then the days of the badge, when the time of the badge will be, and what are the days of the badge, and whatever you can be able to think, you can think here in this planning. Okay, and then to whom this badge is assigned. Okay, we have to also mention to whom this badge is assigned. Here the thing come into the context that is very important, that are the relationships. Here another terminology that's come into the context, that is known as cardinality. So what is cardinality? Cardinality means the relationship between two things with respect to the number of occurrences. Let's say if we talk about these two things, faculty and badge. So what is the cardinality? What is the relationship physically? Do not think about SQL, do not think about programming, just think physically. What is the behavior of badge and faculty together in real world? The badge and the faculty with respect to that particular organization, is the relationship between the two is known as cardinality. So how can you find the cardinality? Just think about that. One faculty can have many badges. One faculty can teach many badges. So this is the relationship. It's very simple. Just think about the real life scenario. One faculty can teach many badges, and many badges are taught by one faculty. So what is many here? The many are badges. So this is how you can find out the cardinality. So cardinality is basically nothing but the number of occurrences between the two tables. Cardinality, let me write here, cardinality. Okay, and it can be one to one and one to many, and there is many to one. So these all are the cardinalities, and many to many. I hope it is clear to everyone. Now let me give you the example of one to one. When you have the one to one cardinality, let's say you have a car and the number plate of that car. So if you find the relationship between the two, one car can have only one number plate, and one number plate can have only one car. So that's a natural thing that is happening. So this is one to one relationship. Alright, so after one to many, after one to one, we have one to many relationship, and inside this one to one many relationship, what we have, let's say the current example that I have given, one faculty can have many badges, and if you reverse the situation, many badges can have one faculty. So one to many and many to one, that's the example of this. And the last thing that we have is many to many. So what is the example of many to many? Let's say one customer can have multiple bank accounts, and one bank account can have multiple customers. So many customers can have many bank accounts, and many bank accounts can have many customers. So that's the example of many to many cardinality. So whenever you are creating the relationships from any of these four cardinalities, there is any one cardinality that is applying on that particular situation. I hope it is clear to everyone. So because you are creating the relationship, the badge should be taught by some faculty, so you need to store the information of the faculty, and it is not a good practice to enter the name of the faculty again in this badge table. Why? Because you will repeat the data. And why are you repeating the data once you have taken the data already in the faculty table? If the faculty name Ali Raza is already stored in the faculty table, then why you are storing Ali Raza again in the badge table? So you have to store something that takes less space. So you have to reduce the repetition. For that purpose, the primary key or the ID column, you have to pick up that ID column and write here like this. So you have picked up the main column of that particular faculty and then stored that and created that column inside badge. Now it will create a relationship between the two tables, that this badge is being taught by this ID of the faculty, this faculty ID, you can say. So this is how you can think and create the tables and their columns or the attributes. After finding the attributes, the third thing we have is the student. So what are the details of the student? Let's say ID or the roll number, whatever you can say, and then the name, and then the class. And now look, we have the students. Now students are enrolled in a class, so there is a relationship between a student and a class. Now think again, what's the cardinality between the student and the class? So one class can have many students, and many students are in one class, so students are now many. So where there you find that the many clause is coming, here you create an extra column of that thing that is not many, that is my class. So you can create the class ID column or the attribute here, that this student belongs to this class ID. You do not store the class name again and again, because you have already taken the batch. The class name or the batch name is already stored inside the batch table, so you do not store the batch name or the class name again. That's what you can create a relational database. I hope it is clear to everyone. So when you are thinking, then these things will come into the context. Now the student is belongs to this class ID. Of course the student belongs to some faculty also. So if you wish to create the relationship with the faculty, so one faculty can have many students, and many students are taught by one faculty. So if you wish to create the relationship between them, then you can use the faculty ID here also. So the students is now related to the faculty also, and the student is now related to the badge also, and I haven't stored the name of the faculty still. I have the ID, I am using that ID again and again. So this is how you can identify the attributes of the physically existing things. Now after this all, let me zoom, make it further, sorry, let me step it out, okay, so that you can easily understood what's going on. Now step number 3. In step number 3, what you can do, you can specify or you can identify what are the strong columns. What are the strong columns inside your identified attributes that you have identified for your tables. So these are my columns, or these are my attributes. Name, if you see the name, so the name column can be repeatable, because let's say if there are 2 Sam, 2 Ali Raza, or 2 Hamad, or 2 Usama, or some other name, so it is not unique. Same is the case with the phone number. Somebody have the phone number, somebody don't have the phone number, so it is also not the validation criteria. But we have the ID. ID is mandatory, ID is unique, so we can make it as a strong column. What is this? In step number 3, we identify what are my strong columns and what are my weak columns. So what I can do, I can mention it as a strong column. I will create it as a primary key. Primary key means this is my main column or the head of the columns. Based on this column I will do everything, finding, searching and all that, insertion, updation, deletion, whatever you can see. Okay, so that's my strong column. Here in the badge we have this strong column, and here in the student we have this as a strong column, and we have this also as a strong column, because roll number is also you can say the strong key. But notice here, primary key is not multiple times in a table. We'll discuss it later when we'll see the primary keys and all that, but I'm just telling you, in step number 3 you identify the strong and the weak columns. So identify strong and weak columns. So guys, what are we are doing? We are planning the database. So after that, after identifying the strong and the weak columns, now we have identified the column types. Either the column is a multi-valued column, let me write here, multi-valued column, or it is a derived column, or is it let's say we have the key columns, that's it. So we have to distinguish that what are my key columns, what are my multi-valued columns. What are the multi-valued columns? Multi-valued columns are those columns that have multiple values. Let's say if the person have 2 phone numbers, then what you can do? So you can now, first you have to distinguish that where there are the multiple columns or multiple values, there the multiple column should come. So you can identify it first. Then you have the derived column. Let's say the address column. Let's say the address is not Nazmabad, block 5, and then Karachi, and then Pakistan. So based on this information you can extract some more information as well. Let's say the birthday. If I am asking the birth here, it is a column from which I can derive another information. based on the birth year I can identify how many years of age is of a particular student. Are you getting me? So a column that can derive further more information is known as a derived column. I hope it is clear to everyone. If you just take the year, you can easily find out the number of years a person is. I hope it is clear to everyone. So that's the step number 4, and then step number 5, you have to design your ER diagram. Okay, so now let me design quickly an ER diagram. And one more thing that you can do first, you can identify the relationships. First you can identify the relationship, then you can create a diagram, no problem. So what are the relationship between these three? Faculty can teach badges, and one batch can have many students, or students are enrolled in badges and faculty can teach badges. So this is how you can formulate a relationship between all the physically existing things that you have inside your scenario. Okay, so this is the brief introduction about an ER diagram. Now let's quickly draw an ER diagram, then we'll wind up. Now I have opened Paint simple tools so that we can quickly create the diagrams. The first thing that you need to do is to create the entities that you have find out. So entities are represented by these square boxes or rectangular boxes. So whatever number of physical entities you find out, you just place like this, and then I have identified 3 things, so I have created 3 boxes, and then write one by one with the name. Let's say these are my faculty, and then you can write here also the badge, and then you can write here students. So this is how you can create a pictorial representation of what you have planned. I hope it is clear to everyone. Now you can create an elliptical shape for the attributes that you have identified. The first attribute, then the second attribute, then the third attribute, and then here for badges you can create the attributes also. So that's first, then that's my second, and then that's my third, and likewise you can identify, you can create the attributes for this badges also, and mention your attributes here. Okay, if your attribute is a strong key, then you specify a dash within that strong key. Let's say the ID of the faculty is the primary key or the strong key, so you can write ID with the underline. I hope it is clear to everyone. And then if you have the multi-valued attribute, so multi-valued attribute is always represented with a double ellipse, is always represented with a double ellipse. I hope it is clear to everyone. So that's a multi-valued attribute. If you have the derived attribute, then that ellipse is like this. If you have a derived attribute, then that ellipse will be like this. Okay, and then place the names of the attributes that you have find out. Then I have mentioned the strong key, the multi-valued, the derived, and then in the last thing is the relationship. So the relationship is displayed with the diamond between these tables, and let me write the diamonds. Okay, so I have limited the space, sorry for that, but this is how you can create the relationship. And what you can write in between this diamond, faculty can teach. So can teach will be written inside this diamond box. So this is how you can create a complete ER diagram. I hope it is clear to everyone. So guys, I have used this paint tool, but I don't recommend you to use this paint tool. You have the professional tools for designing the diagrams, that is Microsoft Visio, and there are other tools like VPUML, Virtual Paradigm, where you can create these diagrams, and you can use some other tools where there the diagrams can be created in a more specified and beautiful manner. Okay, so that's all for today. I hope you have learned how to think, how to analyze the database, how to analyze the situation, how to identify the columns, how to identify the tables, and how to identify the relationships between every table. Okay, so if you do not understand anything, please do write me. Thank you so much. Take care. Allah Hafiz.